All right. Good morning, everyone. My name is Sudheer Matta. I am the VP of Product Management at a new wireless LAN startup called Mist. Yes, I'm a marketing guy, and I'm with the vendors, so you can start the hating now. What I'm going to talk about is sort of what the next generation of networking looks like. We are either stupid enough or bold enough to think that we're going to create a brand new enterprise networking solution, right? And so, again, since I have 10 minutes, I'm going to focus on one thing, is, what do we need in a real good working network? We need good RF. We need it to be easy to manage and operate. Everything we learned the last 48 hours is complexity is going to be our thing of the day every day, right? So we're going to want to make it easy to manage and operate. Indoor location experiences could be very, very interesting, and that's something we need to bring. Now, translating all of this to technology, right? What is the technology we need? And again, I'm going to focus on adding one element to existing networking solutions is what we are going after, right? So, of course, you need RF to work. Of course, you need, manageable, operatable networks. But, of course, you need location that works. But we are going after intentionally adding machine learning to networking. So why are we doing this? We're doing this because, everything you saw in the session before is actually what is constraining wireless today, in our opinion, right? It requires all of you guys, experts, with decades of experience in wireless, to decode all of this. We think there's an easier, faster way. Now, I'm going to go to 3 examples of what we are doing with respect to machine learning. So a simple example, right? A doctor calls in and says, hey man, I was in surgery, I was walking out, I was on a call with the nurse, the call dropped, right? Or a student says, we were in a test, taking a test, and the wireless went down. We were in the boardroom, the meeting, the wireless went down. What if the machine detected what was going on and automatically, dynamically packet captured that and stored it in the cloud? So in case you needed to go, debug this thing, you already had it, right? So this is one example of machine learning. We think networks need to be fundamentally, operationally simple to build and manage going forward. Otherwise, we as an industry will not scale. So another example we've taken, I'm going to talk a little bit about this in BLE. How many of you have done location deployments in Wi-Fi? All of you, probably a lot of you. They're painfully manual if there is anything you can say one thing about them, right? What we've done is we've eliminated the notion of calibration of a location network, period, right? And I'm going to show you an example of demo with that and how we've actually taken, machine learning models and take an iPhone, in a pristine environment, move it to a retail store, move it to a healthcare environment, move it to a hospitality environment. We actually make it work in minute number 1. The APs come on, I have blue dot and navigation working. Right? It sounds too good to be true. We have a bunch of my customers here in the room as well, so you should talk to them and you should talk to us. Another model is how do we get a better metric on user experience, right? All of us do site surveys, turn our homework in, great, high five, beautiful network done. Monday morning when the user comes in, when Biomed goes and buys 1,000 infusion pumps, how do I know those Biomed things are actually having the same experience? Right? So here's what I'm going to do. I'm going to walk you through a demo of our product on how we are incorporating machine learning into things you already know. So we define what we call service level metrics. Here's an example. It's called time to connect. It is how long are you taking to connect. Here's another example. We are taking, in this histogram, this is the power of the cloud. This is every user, every minute in the Mist office, the average RSSI. I want them to be at neg 70 dBm. This is real devices and no overlay networks. This is a proper wireless LAN network with the Mist stack up and down. I have every user, every minute's experience built in. So now I can start to compare for the actual end user experience what their experience looks like. So this is a sort of a real-time site survey into the tool. And then other things like throughput, as I said, we built a stochastic model on throughput. How do you compile throughput? Otherwise, how do you compare capacity, right? Do I have enough capacity in the air, right? So these are baseline metrics we've determined necessary to measure the end user's experience, not with overlay networks, not with span ports, not with, sidebar networks, right? We are trying to genuinely build a brand new enterprise network. If it was built in 2017, how would it look like? So here's what I'm going to go walk through, right? So time to connect in my office is 5.1 seconds. The average coverage is 58.2. Then I'm going to go look into, okay, if this is the state of my network, what is causing all of this, right? Is it DHCP? Is it authorization? Is it associations? Is it, internet services and WAN? Let's get down to it. The machine should tell us the answers, not us staring at god-awful packet capture screens. And it's been 15 years, man. There's got to be a better way. So time to connect. So it can tell me, what it's telling me right here is 107 users in my office took longer than the 2 seconds that we set as time to connect. Now what we could do is we could go down and say, who are these users? Right? So in a lot of environments, if you're in healthcare, if you're in hospitality, if you're a guest-facing environment, you can't touch the end user's device. You don't even know who this guy is. So these are the devices I'm telling you took longer than 2 seconds in our network. Then I baseline. Is it happening with iOS devices? Is it happening with Android devices? Is it happening with 10.2? Is 10.2 worse than 10.1? Or whatever it is, right? You made an image upgrade. Is it better, worse? You added an AP. Is it better, worse? That's what we're baselining, right? Again, with the actual end user experience. Now, this is sort of our estimation, our expectation on if you add machine learning, you can make and build better networks. Now, let's go into, work with me video here. Yeah, so let's go into the authorization. Let's go into, DHCP. Is it DHCP NAC? Is it DHCP unresponsive? Is DHCP stuck? Let's say it's DHCP NAC. Who are these guys that got a DHCP NAC? I can tell you exactly who. You never know these guys. You don't even know these guys showed up. Okay, David Liu's MacBook Pro had a DHCP NAC. Let me dive into David Liu's MacBook Pro. In the last 7 days, he's got 7 bad things happen to his experience. I can now go into, a DHCP NAC, and oh, by the way, it happened, 22nd of February or 16th of February. There's a packet capture waiting for me. And I didn't even know David Liu's laptop is going to have a packet capture. He is going to have a failure. The systems should help us do this shit, right? Sorry. So this is our premise that machine learning can fundamentally augment the network experience. Now, so the next example I'll take is the locations deployment stuff, right? Here's an example of what we've done adding machine learning to a very mundane issue. One of the things when you deploy BLE Bluetooth networks is you have to calibrate these damn things, right? So here we said, okay, all of these iPhones have an antenna somewhere hidden deep inside, usually sometimes the wrong place, right? So we know that. We've calibrated it in a pristine environment, but that's not good enough. When I take this and put it in a retail store in Arkansas or a retail store in Minneapolis, it needs to understand that, right? So it needs to be able to align and create a model that aligns to the RF environment that it went into. That's what we're using machine learning for. So in net summary, I have 1 more minute left. Machine learning will fundamentally change the way we build and manage networks. What Waze did to wayfinding, remember the Garmin GPS? That's the controller in our analogy. Controllers are Garmin GPS devices. Will you buy them today and put them in a car? You buy Waze to put on an app on your phone. That's because they learn from the edges and build better traffic maps for you, right? So if any of you thought this was interesting and amusing, or if it was I was entertaining, please drop by. I'll do a whiteboard for you, and I'll do a full Mist demo. We are a brand new, exciting wireless LAN company. We are excited to be part of this. I'm really, truly honored. I've been in wireless. My master's thesis about 17 years ago was TCP performance over Wi-Fi over wireless, because the term Wi-Fi wasn't coined then. So thank you for the time. Then that's about it, and I'm done.